8.7 Exceptions to the octet rule. There are three types of ions or molecules that do not follow the octet rule. They are ions or molecules with an odd number of electrons, ions or molecules with less than an octet, and ions or molecules with more than 8 valence electrons, which we call an expanded octet. So the first one we're going to examine is one that has an odd number of electrons. Though relatively rare and usually quite unstable and reactive, there are ions and molecules with an odd number of electrons, such as this example of nitrogen monoxide, which has 11 valence electrons. If we do the formal charge for both structures, we'll see that the one on the left would be the more viable formula. The second type is molecules that have fewer than 8 electrons. If we consider boron trifluoride, giving boron a filled octet would place a negative charge on the boron and a positive charge on fluorine. This would not be an accurate picture of the distribution of the electrons in boron trifluoride, since fluorine is the most electronegative element on the periodic table. Therefore, structures that put a double bond between boron and fluorine are much less important than the one that leaves boron with only 6 valence electrons. The lesson is, if filling the octet of the central atom results in a negative charge on the central atom and a positive charge on the more electronegative outer atom, then don't fill the octet of the central atom. The third type are molecules in which there's more than 8 electrons. This is the expanded octet. The only way that phosphorus pentachloride can exist is if phosphorus has 10 electrons around it. It's allowed to expand the octet of atoms on the third row. It is allowed to expand the octet of atoms on the third row or below on the periodic table. Presumably, the d orbitals in these atoms participate in bonding. Incidentally, the shape of this molecule would be trigonal bipyramidal. Even though we can draw a Lewis structure for the phosphate ion that has only 8 electrons around the central phosphorus, the better structure puts a double bond between the phosphorus and one of the oxygens. And we can see from the formal charge how that works out. This eliminates the charge on the phosphorus and the charge on one of the oxygens. Again, the lesson is when the central atom is on the third row or below of the periodic table and expanding its octet eliminates some formal charges, then you should do so. Sample exercise 8.11, Lewis structures for an ion with an expanded valence shell. Draw the Lewis structure for iCl4-. Iodine is in group 7A. It has 7 valence electrons. Each chlorine also has 7 valence electrons. And an extra electron is added to account for the -1 charge on the ion. Therefore, the total number of valence electrons is 36. The iodine atom is the central atom in the ion, putting 8 electrons around each chlorine atom, including a pair of electrons between iodine and each chlorine to represent the single bond between these atoms, requires only 32 electrons. Thus, we're left with 4 electrons to be placed on the larger iodine. Iodine has 12 valence electrons around it, 4 more than are needed for an octet. Practice exercise. Which of the following atoms is never found with more than an octet of valence electrons around it? Sulfur, carbon, phosphorus, or bromine? And then draw the Lewis structure for XeF2.